Okay, there were a couple of questions I'm going to respond to, but I'll respond to those, to everybody. So first of all, just a reminder for the exam, just to do the problems in order. That makes it much easier for me to grade and submit in a single file. And everybody did that last time. And then don't use the question sheet as an answer sheet, because that, if I have to go back and forth, it makes it a little bit harder for me to see what you're doing. So just answer on separate paper, and the exam will be distributed just like the last one was. So again, like, I put it out as an assignment in the exam folder, and you downloaded it, and then you submitted it through that folder. We'll do the same thing for this exam. Okay. Someone had a question about making up WebAssigns. That one was due yesterday and somebody missed it. I'm happy to extend it for another day if you want that. Just send me an email and I'll be happy to do that if you need it extended till tomorrow. And I'll do it like till tomorrow at noon. So if that happened. Okay, someone said, when is our grade going to be updated so we know whether we have to take the exam or not? That's the final exam. This exam 2 is mandatory. You have to take exam 2. Only the final is optional. And the theory there is that you show me on exam 1 and exam 2 that you know the material and you've demonstrated that, then you don't need to do it again. So I just want to make sure that's clear. Okay. Okay. Let me see if there's any other questions that I have. Someone said, will there be a project 4? Yes, it'll be after the exam. I mean, it'll be after the break, and it'll be an optional project. So again, what I'm going to do, let me just make a few announcements, and I'll probably get some of the questions that you might have. I wanted to clear up about the exam, and the exam will be available Thursday, 11/19 from 6:30 until 11:59 p.m. So just to give you a little bit more extra time. So the window will be a little bit longer. And there's a WebAssign review, and I posted it yesterday, but I did not send out an announcement. And there's a lot of questions. I broke it up into 2 parts. So again, one is the trig and one is exponential. And so when you do the WebAssign, I said this on the WebAssign as well as in the announcement, you don't need to do every problem. Just use it to sort of improve the things that you aren't sure of. I think that's the best way to use it. Okay. Office hours, I'm going to post those. I have some today. It'll be 2:30 to 3:30. Tomorrow, I'll extend it by a little bit, maybe, so it'll be 2 to 4 tomorrow, and then by appointment. So I'm going to test that. I'm going to chat that out so you have that. Okay. So if I do have some flexibility in time, not so much today, but I will have a lot more time tomorrow. So if you want to meet with me at some point, just send me an email to let me know. Okay. I had office hours. I want to say one thing about project 3. They were generally quite good. I just want to encourage people to be a little bit more probing in their analysis. One of the skills that I'm hoping to sort of, one of the skills I'm encouraging is sort of look at the numbers and try to make them make sense with words. And so when I ask questions about the data, kind of try to answer the question, try to justify your answer, try to say why. And I made individual comments on a lot of the projects about that. So if there's one thing that could be strengthened, I would say it's that analysis. So I just want to point that out. And I mentioned that on the comment sheet for project 3. And everybody should have their projects have been returned. If they haven't been at this point, let me know. Okay. After the break, I'm going to take care of all the stuff that's after the break. There's going to be a project 4 after the break. So let me write that out. That will be optional, and that will be due on the end of exam week. Also after the break, there will be a review WebAssign that can be used as a makeup. There will be an opportunity to make up quizzes. The details will be after the break. And then there'll be one class after the break. That'll be Tuesday, December 1. And that's when I'll go through everything that happens after the break. I want to focus on the exam now and not so much what's after the break. Okay. So I'll explain all those options. Okay, and again, if you have concerns about your grade, please let me know by email. We can talk about them. My goal is to have a grade through exam 2 by Monday after the break. So you should know exactly where you stand, and I'll have some details about how to interpret all that. So are there any questions about anything in terms of all that detail? Okay, I know someone asked about project 4. I hope that answered the question. I'm just scrolling through, so make sure I answer all the questions. Okay, okie doke. So I don't have a plan today. My first plan was going to be to answer any questions you have about the math. And the second, and I can also give out practice problems. So, okay, so someone said how to determine the equations from the sine graphs. Okay, yeah, let me do an example of that. I'm drawing a graph. I think this is the kind of problem that somebody was indicating they wanted to do. Oops, I have that wrong. Okay, so somebody asked me to do a problem where they determine equations from the sine graphs. Is this the kind of problem that you wanted? And again, the graph keeps going on before and after this. Okay, good. Okay, so the question could be, given the graph, determine A and B. Or it could say, that's one way I could say it, or I could say determine the period and the amplitude. Okay. So the amplitude, which is A, is the max minus the min divided by 2. So let's put a point down here. Okay. Okay. So what would the amplitude here be? Again, I'll give you a chance to work on it, and you can either say it out loud. Well, actually, put it in the chat if you want to answer it. So what's the amplitude? It's the max minus the min divided by 2. Okay. Somebody texted me and they gave me, yep, here, I'll just send it back to them that they had it right. So I'll give you a little bit, another minute, another few seconds to work on it, somewhere between a few seconds and a minute. Okay, so the idea is you look at the max, it's 3. The min is -3. Divided by 2, that's going to be 6 over 2. That's going to be 3. So that's going to be what this is. Okay. How about the period? Oh, yeah, max. Oh, somebody asked me, is the max and the min the y coordinate? Yes, these are the y coordinates. Generally, when you talk about a max or a min, that's what you refer to. Because you're usually thinking about the max of the function, and the function is going to be the y coordinate. Okay. Okay. Okay, so again, think about the period, and there's 2 ways to answer. Well, I don't know. To me, the best way to answer this is just visually. So I'll let you think about what the period is, and then we'll go over that. So what is the period? And that's P, and P is used to find B. P is not in the equation. So what's the period? And you want to think about what a period is and just look at the graph and figure it out. And again, if you want to chat it out to me, if you get it, I can. So the period is 1 cycle, and that's going to be pi, because you just look, it goes up and down once. Okay. Another way to think about the period, if this graph was going on over here, like this point would be it would be that this distance here, this should go down to 3, sorry, the bad graph. The distance from peak to peak is also the period. If you have a hard time seeing the cycle, just look at the distance from peak to peak. Okay, so how do we use the period to find B? What's the formula for that? Because remember, we need to figure out what B is.
Isn't it just 2 pi over b?
Yes, period is equal to 2 pi over b. So we have P equaling 2 pi over b. So then we multiply both sides by b and divide each side by pi. And we have b equal 2 pi over pi, which is just 2. Yep, somebody, okay, good. Okay. Okay, does that, I know there was a question about finding this stuff out from the graph. That, it seemed to me you said that's what you want. I just wanted to make sure. And I also wanted to make sure that people understood that. Are there any questions about this? Okay. Okie doke. So that was one thing we went over. Is there something else you'd like to go over? And again, it can be about anything. You can ask me to try to explain a concept. You can ask me anything you want, any kind of question. And I'll give you a little bit of time to ask a question. If not, I'll come up with a couple of things which I think are important. So again, it can be a concept, it can be how to do a problem, it can be to go over a particular kind of problem. And again, I noticed we covered a lot of material. There's a lot of small things. Oh, rational functions, perfect. Okay. I'm going to give you an example of one. And then we'll probably go to Desmos at some point. Okay. So a rational function, it's a polynomial, which is positive powers of x over another polynomial. And there's a couple of things is that we want to look at vertical asymptotes. And those are places where r of x, looks like, so I'm going to use these, it's going to look like some number over 0, where that number is itself not 0. So, and to find vertical asymptotes, the best step is to solve the bottom equaling 0. So you solve x squared minus 1 equals 0. And you get x minus 1, x equal 1, x equal minus 1. Because this factors into x minus 1, x plus 1 equals 0. Okay. So these are possible, you might even say probable vertical asymptotes. And the way that I test it is I plug x equal plus or minus 1 into R. So I put in 1 into R, and I get 3 plus 5 over 0. So that's going to make it, that looks like this. And then we get r of minus 1. I plug that in. That's going to be minus 3 plus 5 over 0. And again, that looks like this. I get a number on top that's not 0. So there's vertical asymptotes at x equals 1, x equals minus 1. So again, for sketching a graph, I'm going to go over how to do this by hand, but for the exam, you're allowed to use Desmos, so you would definitely want to check with that. So what I know, here's my graph, here's the x-axis, and I know at these points, that the graph is either going to go like this, or it's going to go like this. And I don't know yet. I don't have enough information yet. One thing I can do to figure this out is I can look at the y-intercept. And then I can look at the x-intercept. And the y-intercept is you let x equal 0, and you get it's going to be equal to 5 over minus 1 when I plug in x equals 0. So that's going to be down here. And I look at the x-intercept, and I have to solve the top equals 0. So 3x plus 5 equals 0. X equals 3x equals minus 5. X equals minus 5/3. So I have a 0 here. So notice the graph, it has to go either from here up here or from, so we have to kind of figure out how to use this piece of this information to figure out what the graph would look like. So it tells me over here the graph is going to be negative. So to me, I think the graph is going to go like this. This is my first sketch. It's going to go like this over here. And then on the other side, it's going to go kind of the opposite. But we'll see. We'll have to figure out that in a second. But again, for practicality, I would use Desmos for this. Okay, so that's my first sketch. Okay, now I have to figure out the horizontal asymptotes. And so to figure out the horizontal asymptotes, what I do is I look at the highest power on top and the highest power on the bottom. And I see that the highest on top is going to be 3x, and the highest on the bottom is x squared. And so that simplifies to 3 over x. And what happens, remember the horizontal asymptotes are what happen as x approaches infinity and x approaches minus infinity. And so when this happens, I think I said somewhere in one of the videos that the horizontal asymptote is going to be 0. And what happens is that as x approaches plus infinity, I have 3 over a huge number. And that's going to be very close to 0, but from the positive side. And then as x approaches negative infinity, that's going to be 3 over this is a huge positive number, and this is going to be a huge negative number. Again, and that's going to approach 0 because the ratio is going to be really big. Like, you could plug in a huge number like 1 billion, and I think you'll see that. But since it's coming from negative numbers, it's going to approach it below. So we know that we have a horizontal asymptote at y equals 0. And we said over here that the graph is approaching from the positive side. And this is the only place the graph can change sign. So that means that we're going to have a positive, it's going to be positive infinity over here and approach 0 over here from the top. And on the bottom, we're saying that we're approaching 0 from below. So it's going to look like that. Now, again, I'm not expecting you to kind of figure this out on the exam by yourself, but somebody asked me how I could use this information to sketch. So that's what I'm doing that. So go to Desmos and check if you haven't already. And I'll do that, and I will change the, I'll share the screen as well. Just give me a second to get it set up and go there. Okay, so I'm going to share the screen with the Desmos. And is everybody seeing the graph? If you're not seeing the graph, let me know. Okay, so I'm going to plug this function in. Ah, I got it wrong. So you notice that when my analysis was close, but I was wrong about this. So again, that's why you want to do the graph to double check things. I see where I made my mistake, but I wanted to where I made my mistake here was that I had the asymptote in the wrong place. So that was my bad. So here I'm going to put in the asymptotes so you can see them. So it's the line x equal 1. Okay. And then we're going to have the line x equal, I'm sorry, I did x equals -1. Now I'm going to do x equal 1. And then we had y equals 0. Okay. And so I'm hoping that you can see how the asymptotes work, but I'm going to just scroll down here a little bit bigger. And what I'm hoping you see is that down in the middle part of the graph, you see how it's approaching the asymptotes. The smaller we get, the more the graphs look the same. And then same thing if we look up at the upper half of the graph, we see the graph approaching that vertical line. And then if we look out to the side, we see that the graph is approaching the horizontal asymptote. Okay. So again, to save yourselves time, if you try to do it this way, where you like do it by hand, you're apt to make a mistake, like I did. So I think it's better to go right to Desmos. Okay, I'm gonna, before I unshare, are there any questions about what we're seeing with the graph? So if I ask you to sketch something, I would expect you to go to Desmos, figure out what the graph is, and hopefully it'll conform to what your algebra was. Okay. Okay, I'm going to unshare. Okay. Somebody asked me, yeah, let me go back to the graph. That's a very good question. Somebody asks me if y equals 0 is correct because it touches the graph. And I assume you're talking about right here, where it crosses the x-axis. If you are, that's okay, because what the horizontal asymptotes is long-term behavior. What happens when x is really, really, really big. So it's okay, like near 0, where x is really, really small comparatively, for it to cross the graph. But once you notice that once it crosses, it doesn't touch anymore. I just want to make sure I answered that question. Okay, it did. Good. Okay, great. Okay. So that's a very good point. When we're looking at asymptotes, we're looking at long-term behavior, both vertically and horizontally. Like it's possible, in answer to that question, I'm just going to make up a graph. We could have something that looks like this. And then the horizontal asymptote over here would still be y equals 0. It doesn't matter that it crossed it here. We're looking to see what happens way, way out at the end behavior. Okay. Okay, so, and then did I answer somebody in the original question about rational functions? Did I answer your question, or at least for this particular example? I was going to go in a little bit more detail. Okay, good. So here's the idea, and this is, I think, what you want to kind of understand why this happens. We have a rational function, and we're going to have something that's degree n over degree m. So this was 3x plus 5, x squared minus 1. So the bottom degree is 2, the top degree is 1. Okay. Unless we get, well, I'm going to give you I'm going to say that there's no common factors between the top and the bottom. Then if the degree of m is greater than n, horizontal asymptote at y equals 0. So here we have the degree 2 greater than 1, the bottom overpowers the top. If we have the degree m less than n, so let's reverse things and look at this. I can go through the problem in detail if you want, but I want to give an overview now. Then we're going to have a horizontal, there's going to be no horizontal asymptote. F of r of x is going to approach infinity as x approaches both plus and minus infinity. Infinity or minus infinity. So the upshot here, we have m equaling 1, the degree on the bottom, the degree on the top is 2. So we have 1 less than 2, no horizontal asymptote. And if you graph this, you'll see. Okay. And then finally, if we have m equaling n, so let's say we have something like this. We're going to have a horizontal asymptote at 3, 4. And the way that I figured that out is I looked at the highest power on top and the highest power on the bottom. So I looked at 3x squared over 4x squared, and I canceled the x squareds. So that's for horizontal asymptotes. This is going to work as long as there's no common factors. So I'll do an example with a common factor. Okay, I think I went over this in one of the videos, but it's a good handy way to look at the problem and know what's going on. And so maybe we'll do a quick one. Okay. Someone said how to graph y equals minus 1/2 by sec x. I'm not going to cover that on the exam. I'll talk more about that. Okay. Okay. So vertical asymptote, again, there's going to be no common factors between the top and bottom. So let's say we have something like, I'll do a different example. And it really doesn't matter what's on the top. So this has no effect. So I'm going to do x squared plus 3. Okay. So what I do is I solve the bottom equals 0. So I would solve x squared minus 3x minus 15 equals 0. So I maybe make this a 2x because otherwise it's going to be too hard to factor. So x minus 15, I know it's going to factor into something that looks like this. The numbers I put here and here have to equal 15, but their difference has to be 3. So I'm going to say, well, 5 times 3, 5 minus 3 is equal to 2. Well, that's going to work. So I'm going to put a 5 there and a 3 here. But since this is minus, one of these has to be plus. So since the sign here is minus, that means the biggest is going to be minus. So that's what I get for my factoring. And so I have vertical asymptotes at x equals minus 3, x equal 5. And then I would have to analyze or graph to figure out what the more specific behavior is. Okay. So let me do an example. Let me do this one as an example all the way through really quickly. And then that way, then we'll see where we are after that. Okay, so let's do what we can before we graph it, and then we'll graph it to see what it looks like. We can see there's a vertical asymptote, x equal -2, x equal 5. What's the horizontal asymptote? And we'll go back to this. M is equal to n, so we just look at the highest powers. So what are we going to get when I look at the horizontal asymptote here? Again, you can either chat it out or say it if you want, doesn't matter. What's the horizontal asymptote going to be? And again,
Is it 1?
yeah, it's going to be 1. We have m is equal to 2. So we look at the highest powers, and that's going to give us 1. So it's going to be y equals 1. So I'm not going to try to graph it because that's not a skill you need for the exam, but you can see it's got to fit this pattern. This is going to be x equals 5, x equals 2, and y is equal to 1. And so we'll just go to Desmos and do that. I see what I did wrong. Okay. So clearly I made a mistake in here. You tell me what I did wrong. And I made a mistake in factoring. When I wrote it over here, I had it different than how I factored. What mistake did I make? Yes, the x should be 3, not equal to 2. That's what somebody texted out to me. Look, when I factored over here, and then when I copied it x plus 2. So that's not right, so I have to change that. And then let's go and look back to the graph and see what happens. So you couldn't see what I was doing because the screen was sharing. I'll show you what my mistake was. Oops. I'm just trying to zoom in so you can see it. Now that looks better. Sorry, there we go. Okay, I'm not going to worry about that. Sorry about my graph. Need to zoom out a bunch. Forget it. Okay. But what I did is when I originally did the problem, x plus 3, x minus 5, when I went over here, I miscopied it. And so I had to do the change. So again, that's something that could happen during an exam. And that's one of the good things about a graph, doing it both ways, is you say, oh, something's not right here. I got to figure it out. And you have enough time on the exam to be able to do those kinds of things, which is why I like to give a long exam. I mean, exam where you don't have a time constraint. Okay. So I'm just going to pause here. I want to show you what happens with common factors because that's important. And then, but I'm going to ask, did that help? Do you have any questions about any of that stuff with rational functions? The person that had the question, does that help? Okay, good. Okay, so I'm just going to do one more where I have a rational function, where I have a rational function, but there's going to be a common term. Okay. So I look at this and I notice that I have a power of 2 on top, and then m is equal to 1, the exponent on the bottom, and it looks like I might have an, I also notice that x plus 1 equals 0, where x is equal to minus 1. But then I'm going to look on, but if I plug r of minus 1 in, I get 1 plus 2 minus 3 on top, and minus 1 plus 1, so I get 0 over 0. Now, all what I said before doesn't always hold. So we got to do the factoring before we figure out what's going on. So this tells me that there's a common factor. So then I look up here and I say, well, this factors into x minus 3, x plus 1. Again, I'm doing it quickly, but eventually you'll get to that point. And so I cut that out, and really what happens is that r of x is equal to x minus 3, except at x equal minus 1, where r does not exist, because you get division by 0. So when there's a common factor, you have to factor. So if there's a common factor, you factor and then analyze. So the bottom line is that x equals 1 minus 1 is not a vertical asymptote. So there are no vertical asymptotes. However, when I look up here for the horizontal asymptote, I still have the degree of the top bigger than the degree of the bottom. So there's no horizontal asymptote either. The graph goes off to infinity. Oops, I'm frozen, so sorry about that. Let's wait and see what happens. Good. Sorry, I froze there for a second. So we looked at the top exponent's bigger than the bottom one, so there's no horizontal asymptote, and the graph goes off to infinity or minus infinity at the end behavior. And again, you can go and graph this, and we'll see, which we'll do real quickly, and we'll see it looks just like this graph. It looks just like that. So let's go back and do that. Oops, sorry. Sorry, I don't know what's going on here. I'm just being a klutz. So I'm going to go back to just, I'm going to go get rid of this, go here for a second, and then come back. And so our function was y equal x squared minus 2x minus 3 over x plus 1. And as you see, it looks like a straight line. I'm trying to get to exactly to the point 3. It's not, it's, yeah, okay. Sorry, if you go to the, I meant to point minus 1. If you get exactly on that, it's undefined. And so if we do the graph y equal x minus 3, you're going to see it looks exactly the same, like exactly the same. Okay. Okay, I don't know what, I think I've said enough about vertical, I mean about the 2.6, but if you have any other questions about it, let me know. Okay, somebody asked me about how to graph y equals -1/2 secant. Again, I would just go to Desmos, but I'm not going to cover this. I mean, you may see the secant a little bit, and you'll see it in calculus courses. If you take not business calc, but if you take Math 50 or Math 70, but I'm not going to cover it. And it's really what's important. If you understand sine, cosine, and tangent, then that's really what I'm focusing on. So again, I'm not going to cover that. But again, you go to Desmos and see it. Okay. So other questions. And just I want to say with 2.6, notice that you need to review some of the stuff that we did earlier in the semester, just to make sure that you understand a little bit about solving equations and stuff like that. So don't leave that behind. Okay. Somebody asked about the application problem for the plane. Okay. I want to make sure, I know it's in the textbook. So the idea here, let me go on a fresh piece of paper. So the idea that somewhere up in the sky, there's going to be a plane. Sorry, I can't draw a plane. It looks like a shark, but, and then you're down on the ground here and you're looking up at the plane, and that forms a triangle, kind of a right triangle. And this would be the height. This would be your distance for the plane. And this would be the angle of elevation. Because that's, if you're looking up, that's what it looks like. So is whoever asked this question, is this the question you wanted to go over, this kind of thing? Okay, good. Okay. So the question is, let's say, I'm just going to make up numbers. Let's say that, that this is 10,000 feet. And, for some reason, that this is 60 degrees. Okay. And the question is, what is D? So the key with this, any angle of this is an angle of elevation problem. So if you see those words, you know that means, okay, it's going to be something like where I have a right triangle. And I need to find two sides or one side in an angle. Okay. So then the question might be, what is the distance? And so I look for there's a couple different ways to do this. I am going to I'm going to form the sine ratio. And then 60 degrees is the same as pi over 3. So I could give the problem that way. And then I have to plug whichever version you want. And I know that the height is 10,000. And what is this equal to? The sine of pi over 3. And it's one of those famous angles, and that again, I suggest having on a formula sheet or something like that. So if you can figure out what this is, then notice you just have one unknown, the D. Oops, I made a mistake here. What was my mistake? So what mistake did I make? I was way too worried about solving the problem that I didn't think about what I was doing. What is the sine ratio? And so what's my mistake?
Opposite hypotenuse?
Yeah, opposite over hypotenuse. I didn't do it right. The hypotenuse is D, and the opposite is H. So I'm going to do this again. We know that the sine of pi over 3 is equal to hypotenuse height. That's what confused me. Notice I used height, and I said, oh, when I looked at it, I said, oh, that's hypotenuse. That's what messed me up. My choice of variable here for h. So again, when you do a problem, when you go back over it, you say, oh, is that really the sign ratio, or did I make a mistake? Okay. And so now I look at it again, that d is my unknown. I know what h is. And what's the sign of pi over 3? And again, if you get out your calculator and do it that way, you don't have to give me an exact value here. But I would look at the chart or something like that, or get out, or just, use a calculator or some kind of calculating device. It's certainly 60 degrees, but what's going to be the actual ratio for 60 degree? That's one of those famous ones.
Can I say it out loud?
Yeah, go ahead.
Square root 3 over 2
Yes.
is what I got.
So yes, square root of 3 over 2, or you can write it as a decimal on the exam. I'm not really going to worry about that. So that's the equation that we need to solve. And so I'm going to multiply both sides by d to get rid of the d, and I get d times square root of 3 over 2 is equal to 10,000. And then I need to clear this number, so I'm going to multiply both sides by the reciprocal. That cancels and that cancels. So I get d equals 10,000 2 over square root of 3. And so again, I'm going to accept this as an answer. I might say something like write it as a decimal, write it as a decimal. If you were doing this in WebAssign, you'd want to get rid of that square root of 3. So you'd multiply it times square root of 3 over 3, and you would get d is equal to 2 times 10,000, which is 20,000, square root of 3 over 3. And that would also be that would be an acceptable answer for WebAssign. But I'm not going to worry about the format on the exam, unless if I say otherwise. Okay. So did that answer the question, the person that asked about that? Good. Okay. And are there any questions about this? I did this kind of messily to try to keep it on one page, but I can kind of rewrite it in a way if that would be helpful to anybody. It won't take very long. Just let me know. Okay. So the key, if you have a trigonometry problem, there's one key is like to try to set up a right triangle, and then use what you know about trigonometry for that. Okay, are there other questions, or would you like me to come up with a question? Are there questions? Most of the questions have been about trig, but are there questions about the logs? Okay, practice problem for a log, good. Okay. So I've been told I say good a lot when people ask a question. And it's not about oh, you have a question about it. Good, that's good you have, sorry. So anyway, so let's look at, here, let's do a simplify. And someone asked about finding the domain, so I can do that. So simplify using log rules. So we have x cubed times y squared over z minus 1 quantity to the 5th power. Okay. Now, remember this rule. If you have the log of A times B, that's equal to the log of A plus the log of B. And the reason for that is when you multiply things which have the same base times each other, you add the exponents. And then the other one is when you have the log of A over B, you subtract. And again, the idea here is that when you divide like base numbers with exponents that have like bases, you subtract the exponents. Okay, so the thing here, it looks like both, but since I have two things on the top over the bottom, I'm going to do the subtraction first. So I'm going to consider that my A. And then the bottom is going to be my B, and I'm going to use this rule. Okay. And then I've got another rule you want to think of. You have the log A to the n. You just bring the exponent down. So, but before I can bring, since these don't have the same exponent, I have to do this rule first over here. So I'm going to consider that my A and that my B. Use this rule. Log x cubed plus log y squared minus log z minus 1 to the 5th, and that's all inside the log. Okay. And now I can use this rule, bring the exponents down. And I bring that 5 down. Okay. And notice I can't simplify this because we don't have a rule for the log of A minus B inside it. And there's no rule for how to simplify this. And that's a minus sign there in case you read it. Okay, does that help? Or was there a different kind of log problem you'd like to see? Oh, actually, I want to do another log because I think it's also an important skill. And let's say we have to solve an equation like 3 to the x equals 5. And remember, it's sort of the we have most calculators have a button for the log without any number, and you reinterpret that as log 10. And then there's a natural log, and that's really the log base e of x. So neither of these numbers are going to work for this log. So I have to know the change of base form. And the way that I remember that is it's a fraction. I have a log on the bottom and on the top, and it doesn't matter what base it is. It's just going to be the log b over the log a of whatever base I want to use. And I'm going to use this base just because. I could use natural log and get exactly the same answer. Okay, so I need to use that rule. So you begin by taking logs of both sides. Actually, you know what? I didn't even need this, but I wanted to sneak it in there. Okay, so I take log base 10 of both sides. Since the log is 1-to-1, the log is one of those things that you can take. Sorry, it's getting blurry, so I just want to have it refocus. A log is one of those things you can take both sides of. Okay, now I simplify by bringing down the x. And then I need to get x alone. So I divide both sides by this. And that's going to be my answer. So I'd have to look that up. all I know about the answer, it's going to be greater than 1 because this number is bigger than that number. So I would have to look this answer up. And if somebody wants to do that and text it out, that would be, yeah. Okay. So again, someone said practice problems for logs. I think the most important are the simplification using these rules and also, how to solve an equation. Okay. Well, someone said finding the domain of a function. And so I'm going to find the domain of the log. Okay. Now you can look it up and you'll see that the domain is 0 to infinity. And if you graph it, you'll see that as well. The graph will look something like this. And it never touches, and there's no graph over here. So again, that's just one of the things you want to know. But I think the best way to see this is to look at this function, its inverse function, because this is the more natural function. And we specify that that number base is going to be greater than 0. So let's use 10 as an example. Now notice if I multiply 10 by itself, it has to be positive. There's no way to multiply 10 by itself and get a negative number. So this always has to be greater than 0. And then notice when I undo this function, if I take the log of this, it would look like that. So using base 10, it would look like this. This has to be greater than 0, which means that that has to be greater than 0, because this is what goes there. So again, you might have in your notes, you can find the domain of the log, and you should know that based on this stuff, but this is an explanation why. Okay. So the person that asked about the domain problems, would you like me to do another one or a different kind of function? Oh, while you're thinking about that, okay, I got an answer. Okay, so I want to look at this here. And we saw that you see that the graph, if you graph it, will look something like this. And by looking at this, you can see that according to the graph, the domain is minus infinity to infinity. And the range is going to be 0 to infinity, always positive, like we just said. That has to be greater than 0. Now, the reason the domain here is because if we plug in 10 to a negative number, that just means a reciprocal. So if I had 10 to the minus 8, that would just be the same as 1 over 10 to the 8. And that's the same as 1 over 10 quantity to the 8. Since that's positive, remember A has to be greater than 0. Any power of A is going to be positive. So it's okay. The reason we can plug in this is because it's okay to plug in to use negative numbers as exponents. Okay. Okay. So again, for logs and exponents, it's one of the things the review can do is it can help you things that didn't make sense before that you just kind of memorized. You go, oh, that's why. It's that second or third look through that gives you that. Okay. So you tell me, what's the domain of y equal cosine x and y equals sine x? And then y. And remember, let's focus on the cosine. What do we plug into the cosine and what do we get back? Well, you plug in an angle, and you get back a ratio. And we know how to make that ratio negative, so it's actually plus or minus a ratio. Okay. So what numbers are permissible for angles? So the question is, what's the domain of this? Comes down to is what numbers are allowed for angles. And what's the answer to that? Can we use only certain numbers for angles, or can we use any number for an angle? And why? Okay. Okay, so I got a couple of answers, but I'm going to look at this. I'm going to make a ridiculous number and 36,000 degrees. And what that does, that's an angle. That's an allowable angle. So I just go around this 360, that's 360 times 100. I go around 100 times. That's my angle, and end up back where I started. So someone said that angles had to be positive. No, they can be negative because of that. I went the wrong direction. Focused on the big picture, I can miss the small picture. Negative, you go clockwise. So I go this direction 100 times. And I end up there. So it turns out that angles can be any real number. And someone said here that the range has to be between -1 and 1, and that's right. Okay. So I have a question for you, and it's one I haven't asked yet. If we look at the cosine theta, you notice that we're saying its range is 1 or -1. Now, why is that? And let's look at a triangle. Adjacent, opposite, hypotenuse. Remember, this cosine ratio is adjacent over hypotenuse. So what's the biggest side in the triangle? In any right triangle, it's going to always be true. Yeah, so this is always going to be, this is always going to be bigger or maybe equal when we talk about this angle being 90 degrees on the unit circle. So when we have a smaller number over a bigger number, that has to be less than or equal to 1. Because hypotenuse is larger than adjacent, larger than or equal to, because we're going to use a unit circle. If we divide both sides by adjacent, sorry, I made that overcomplicated. Let's try that again. Okay. If I divide both sides by the hypotenuse, that cancels and is equal to 1. So in some ways, it makes intuitive sense that this is going to be bigger than this, so this ratio has to be less than or equal to 1. But this is a way to see it algebraically. Okay. And then since we have that trick on the unit circle to make ratios negative, we know that the cosine has to be greater than -1, but less than 1. Okay. So it's all because the hypotenuse is the biggest side. Okay. Just to give you a little bit of understanding about that. Okay. So those were some questions about domains and ranges of trigonometry and also of logs and exponents. And those are the big things. If I had a rational function, I should say this since we've been talking about this. So we had 3x plus 5 over x squared minus 1. That was r of x. Remember, our domain is equal to r minus either numbers which cause division by 0 or negative square roots. Now there's no square roots here, so we don't have to worry about that. So we have division by 0 here. We solved this as we did earlier, and we saw that x was equal to plus or minus 1. So it's going to be r minus these two numbers. So I'm using advanced notation there, but the way that I would think about this would be minus infinity to minus 1, parenthesis, minus 1 to 1, again, parenthesis, because we can't plug in minus 1, and then parenthesis minus 1 to infinity. Or you could say all reals except plus or minus 1. Okay. Okay, so I think that's a good summary of how domain and range might affect this exam, but if there's other questions about that, let me know. Okay, so we've been here an hour and 15 minutes. It's 1:45. I'm happy to stick around and answer questions for individual questions for a bit, or if there's if people have other questions they want to put to the whole group, I'm happy to, you can stick around. So I'll leave it up to you. I'll pause for a second while you think of questions, and if you feel good and you want to leave, that's fine. Do so, and then if you want to stick around and ask more questions, do so as well. I'll be happy to answer them. And again, before people go, I really want to wish you good luck. The exam will be very similar in format and content. And I tried to spell out what you need to know on the study guide. But some of these why questions, I might ask you to some short 1 or 2 questions about why. And so I went over some of those today as well. Okay, like I say, good luck, study hard. Let me know if you have questions. I have extra office hours, and tomorrow morning, I'm relatively free, so I can also have some office hours like after 10 o'clock, or appointments if you want.
Thank you.
You're welcome.
Thank you.
Thank you.
You're welcome.
So I had a couple questions, Professor.
Certainly.
So just to make sure there's no class Thursday, right? It's
Right.
Just the final.
You just do the exam. It'll be just like the last one. I'll make it available at 6:30 in the morning, and then
Okay.
and then you'll have until midnight to hand it in. And there's no class.
Is it,
Yeah. And once the exam starts, I can't, once 6:30 hits, I can only answer like, did you make a typo here kind of questions, not like, how do you do, I can't do any, how do you do this question. Yeah.
all right. And you gotta turn it in one file, right?
Yeah. Yeah. So just the best way is to take pictures and then you can just paste them into Word. There's other ways to do it, but that's one way to do it.
All right, thank you. That's it.
Okay. You're welcome, Brendan. Okay. So I assume you got questions, Isabella and Ciamora?
Yeah, I just have a question on you. I don't know if you sort of answered it for WebAssign. I
Uh-huh.
missed I only did like 10, 10 problems, and I don't know. I usually on top of those, but for
Yeah,
some,
I can
I just
explain.
want to know if you're willing to like open it for a day or just have like a makeup thing
Well,
for
what I'll
it.
do is I'll open it till noon tomorrow. Um, and then, you know, I mean, it'll be useful, I think, to study for the, it's not bad exam prep. So it's not like wasted time, but will that work?
Yeah, sure. Yeah,
Okay.
I just want just a
Yeah.
lot more time on it.
Yeah. Okay. And then, like I say, I'm going to drop two, and then there'll be a makeup one, a review one after the break.
Yeah, okay.
Okay. Yeah. I'll go in and, in fact, I can open it right now, so it'll be ready. I'll do, you don't need to stick around. I'll do it right now, and then it'll be ready in a minute or so.
All right, thank you.
You're welcome. Isabella, are you here or their internet? Okay, I think you're not here. Okay, so if this is the, the class video, and I just want to sort of repeat a couple of things that I said, so you have a record of them. So exam 2, Thursday, 11/19. It's mandatory, and it'll be open 6:45 a.m. to 11:59 p.m. Okay. And then in terms of other things for the exam, I'll have office hours Tuesday, 17th, 2:30. I think I said, what did I say? $3:30. And then Wednesday, tomorrow, 2 to 4. And then I have appointments. And I would say 10 to probably, like, let's say 1 p.m. is a good time for appointments on Wednesday. Okay. And just a couple of more small things. All problems in order. In one file. And don't write on the answer sheet. Okay, I think that's it. Okay, good luck.